What I'm going to look at today is repairing an E4419B power meter and power sensor. So when I bought this off eBay. It was actually sold as working, but I had a little bit of doubts about that. However, the price was too good, so I couldn't resist, and I went ahead and bought it. And the things that I was worried about was actually when this was advertised, there was actually a cable attached to this, a power sensor cable, but it had been cut, and it was heat shrinked onto the back of this unit. There was also a small bit of Type N coax actually on there as well. But yeah, that was also heat shrinked on as well. Now, that might seem like a bit of a red flag, but to me, I've seen a lot of old test equipment cut out of test sheds or racks where it's been installed, and that's exactly what I see here. Somebody's actually just ripped this out. And what that usually means is that it's probably in working condition. At least the sensor would have been. So they would have probably just come along and decommissioned the thing, ripped it out, cut the cables, which is a bit brutal, but there you go. So I expected it to work. But unfortunately, when it got here, it didn't work. And I'll show you the failure mode. So when we apply power, you can hear a fan spin inside. You can see this front panel light goes on. But nothing, absolutely nothing happens. Now, the signal path did a really nice repair of something similar, and what he noticed was, in this top corner here, he could see some writing, but I can't see even that. Now, I have to say, when this arrived, it did briefly power on. It didn't do anything. I didn't get the chance to test it, but briefly I saw a display, but what I saw was the LCD crystal was fading, so it looked like a power problem. So I think there's probably something perhaps to do with the display here that's at issue. So how I'm going to proceed is I've done a couple of things. First of all, I bought a power cable, so I have a new power cable to actually test the sensor with it. I've also gone and bought a replacement battery for this because it's notorious that the batteries in these things are dead. So I'm going to replace the battery inside. But the first thing I'm going to try and do is talk to it over GPIB, because that'll let me know if this is something more fundamental, like the system-wide power, or it's something isolated to this display. But I think it's some kind of power issue because of the way the display was behaving. Okay, let's get started. So I removed this back plastic cover and noticed the first of the repairs to be done. So I'm going to have to get a little bit of epoxy or something and essentially glue this back in, which I'll do. But once that back two screws are off, then we can remove this from its case and take a look on the inside. So inside this unit, from the signal path teardown really does a good job of talking about it. But you can see I have my sensor cards here. Inside this is actually the switch mode regulator, which is quite hard to remove. There you are. Great. So we have the switching mode regulator here. And then there's a main board down at the back. Right, there's the battery that I'm going to try and replace. And here's the power lines, which I can check. So there's a set of inductors filtering there, the supplies. So I can just about read 5 volts here on this middle one, minus 12 here and plus 12 here. So I'll check the power rails there in a minute. And if they're okay, what I'm going to do straight away is just replace this battery. Because I know that there's a good chance that if this isn't working, it's somehow holding up the rest of the system. If that works, then what I'll do is I'll remove these sampling cards. I'll detach the channels. It's quite nice. I didn't realize that they actually had front and back connectors for these two channels. And I have got the dual channel version, so I've got 2 of these sample cards. I'll remove those and try and power up just to isolate those away from being any part of the problem. And if it's still a problem, then what I think I'm going to have to do is start checking the voltages on the display board. So I'll take this front thing off and start looking at that. There is some kind of protective plastic cover here over these front switches, and so you have to push this back to be able to access them. Okay, let's try replacing this battery. I think I can get at this battery. It's pretty well indicated via these 2 ports here, so I'll desolder the battery from here and put in the new one. So I don't seem to be able to get anywhere near enough heat in to desolder this, so I'm just going to savagely cut it open. I'm not actually slicing into the battery here. Oh, I did verify, I should show actually. the voltage on this battery was actually about 0.1 millivolts. So yeah, 170 millivolts. So that's well and truly dead. Let's get on with cutting it out. It's actually quite tight to get in here. That capacitor there is making it very hard to get there. Normally what I'd do is actually probably slice this off lower down, but as it stands I can't get in there. So I'm stuck with trying to break this off. So it's required even more brute force because it was actually stuck down, but now I've actually cut through this top cap here, because I knew that this top cap's just pressed on the top. You can actually get through it quite easily. It's not actually part of the battery. Right, that's good. So now what I'm going to try and do is just either wiggle this free, or I don't think I can get my side cutters in there. A little bit of twisting action, I'll take that off. Then I'll have to clean it up afterwards. So there it is. Free. The thing is, my replacement battery, doesn't have the same type of connections, so I'm going to have to figure out something here. So what I've done is I removed this battery, but you can see I've made a bit of a mess out of these battery terminals. Yeah, I had to kind of really savagely attack this one. And to save me kind of making the same mess again whenever I come to replace this, what I'm going to do is actually install the battery using a small section of lead. So I'm going to heat shrink this and probably tape it to the board. There is a space for a zip tie, but I'll put a heat shrink around this just so the ends are covered. And then I'm going to solder this wire in just so I can easily replace this next time. So I couldn't resist once putting the battery in. I just want to see if that made any difference. But no, clearly, although it's powering up, nothing on the screen. So I think I'm going to start removing things, remove these sampling boards, and then check the voltages on the front. Okay, so now I'm going to try removing these sampling boards. So we're just going to push these. I've just removed one cable here. So I'm going to remove this one. There's ribbon connectors. Once I've got them clear, I should be able to remove one board and then move on to the next. Okay, let's do the next one. Right, come on, I can't resist. Let's try powering on one more time. See if we actually get anything out of this. And nothing. Okay, so I'm going to try and take off the front panel. I think there's just one screw here. And once we've hacked that out, let's see what happens. So indeed, once you've got that screw off, you've just got to kind of lever this corner off, and then it's off. So I think I'm going to do the same around the other side. So I missed something. It didn't feel right, and sure enough it wasn't right. There's a little tab that you push down here, and that allows this plastic bit to pull in. And once that plastic bit pulls in, you can easily extract the front panel. So yeah, watch out for that one. I was forcing it. It didn't feel right, and sure enough it wasn't right. Okay, let's have a look at this. I've got this front panel LED here. I can check what the voltages on this LED panel is, and try and identify where those voltages are coming to here, because I think the screen is all one piece off this one ribbon. Yeah, so there's a capacitor there that I can measure the voltage across. See if we get something sensible like 5 volts. So we can see that this whole display assembly is held in by these little metal tabs that have been bent in. So I'll just bend those out. And what that'll do is it'll allow me to remove the display assembly. I don't know why I think it's the display. Do you know what, I really should do that GPIB thing, so I'll do that next. Just convinced at this point that this is a display issue for some reason. So I actually managed to remove the screen from the front of the unit. How you can extract this LCD module is actually just by bending in a series of tabs. So there's tabs here and just over here as well, and there's corresponding ones on the top as well, and they just kind of pinch into this unit and keep this together. There are some extra tabs which I've already bent out the way to actually remove this module itself, but I don't actually need to do that anymore. It's just a couple of 4 tabs around the outside of this unit that held it down. I know I'm kind of digging away at this thinking it's an LCD issue, but one of the reasons why I wanted to take this off anyway is because of this staining here. So I think this is just something that'll clean off with a little bit of, well, I don't know, this darkening. Yeah, I'm scratching it off, I think. So I think I'll just take a little bit of isopropyl alcohol and just clean that screen up. So just a bit of alcohol on the sponge. I can try cleaning it. We'll see how that works. And that's doing nothing. Interesting. So that burn-in might be somewhere a bit deeper. So in order to actually separate these two sides of this screen, to actually access the LCD layer, you have to bend back all this metal plastic, this metal that's holding in the plastic. However, I noticed there's a tip of a screw head here, and if you look at an angle, there it is. So the only way to really get at this front LCD is to undo that screw there. So we'll give that a try. So removing that screw allows me to then actually separate the backlight from the LCD itself, and perhaps the zebra strip as well. No, okay, that's not the case. So if I just remove this, you can see we can have the glass of the LCD and some interesting bits. So the contacts seem to be for the LCD along the bottom there. It's an interesting colour. Oof. Okay, this all comes apart. Right, let's pull this apart then. So you can see here that the discoloration is with the LCD itself, and it's held against that background. So do you know what, that might actually be screen burning or something. Let's try and give it a little clean. I think I'm going to use a fresh one of these, but we'll give it a little clean with isopropyl alcohol, see if we can get that LCD to be clear. So this is the front. Let's hope it's not whatever the LCD is. Makes the LCD work. Let's hope it's not the liquid equivalent of magic smoke. Oh yeah, look at that. So it definitely looks better. That is staining at the back of the LCD. What a weird place to get it. I'm going to keep cleaning and just try and polish this up so that it's actually usable. But what a weird place to get some black dust. Okay, so now the LCD looks a lot better. It's nice and there's no more of that dark shadowing that I was just seeing behind it. Still doesn't work, but at least I'm not going to worry about that anymore. Okay, so that's the LCD module back together without that kind of dark shadow on the screen now. But I don't think my problem's here, and I'll tell you why I don't think the problem's here anymore. So, powering up the unit, what I did was I actually put in my USB to GPIB converter into the back, and then tried to reach this unit, and I couldn't. So I started to think, okay, this is no longer kind of a problem with just the display, it's probably something more with the actual unit itself. So I started to try and debug the power, and what you'll notice is I have these power lines up here. So these come from the main PSU, but these are actually on all the time. So those ports are always supply minus 12 volts, plus 5 volts, and plus 12 volts to the board. But when you actually operate the soft switch at the front to start the system, what happens is these 3 MOSFETs that we have in the system actually enable those rails for the rest of the unit. So here we have the plus 12 MOSFET, this is the minus 12 volts MOSFET, and over here is the 5 volts MOSFET. So the first thing I did was I attached the panel and started cycling the power button, checking the power out on these, and it looks fine. So it looks like power's getting to the rest of the board. This is where I got a little bit depressed, because this is starting to look like a really problematic system. So what I'm going to do now is I've actually just loosened this piece of coax here that's for the power reference module that's here, and what I'm going to do is lift out this expander board here. That should be the next thing. I think that just comes straight out once you've removed the measurement boards. Yep, there it is. So I'm going to remove that, and then what I can do is tilt the system over, and if I remove these screws, I should have an appropriate torques. So there's 3 screws, one here, one here, and one here. And if I remove this retaining bar here that's used to retain the front panel connectors, let's just get that out. There we go. I think this just slides out. Yeah, there we go. So I did just need a little bit more tender loving force. Oh, and to actually remove the power connector. Okay, so there's that piece, there's the 12 volt fan, and there we are. So we can remove the main board. So what I'm going to do now is operate this with its front panel. I might clean it up a bit, but operate this separately and start to explore things like voltages around this main CPU. Yeah, and just see what's actually happening here. See if this runs as well, just as it is, just to see if pulling it out of the system resolved its problem. Nothing obvious, so it's time to check the voltages around the CPU and see what's happening. And then what I'm going to do is, I know that the LCD wasn't powering up, and yet I know, for example, this test point here was measuring 22 volts, which is, I believe, I mean, I did read the service manual, this little inductor here and this capacitor here, I think are all part of a DC-DC converter to supply 22 volts to the front LCD through this connector here. So the 22 volts is there, but it doesn't seem to be getting through to the LCD. So I wonder if the CPU itself has to actually enable somehow the power supply to the LCD, and that's the issue. So the CPU is the issue, or if there is some issue with this DC-DC converter getting through the flex connector to the front panel. But I'm surprised, because I would have expected this system to have at least given me something on the GPIB then. I was looking at the system under my microscope, and what you see here is actually the microcontroller, and sure enough, just there I spotted something on one of the pins, and it looks like a solder bridge. Now, I don't think that's my issue, because that solder bridge has been there the whole time. So a bit of an odd one to actually find that there, and I wonder if it's deliberate or not. Anyway, the two pins, if I look at the data sheet, the two pins that are soldered together are the halt and reset pins. And I monitored the voltage actually on this point here, just here, which is the reset one, and it's low, and it's the but it's a not reset pin, so it should be high. So I'm starting to think that actually the CPU is being held in reset somehow. I checked for clock. I can see clock coming to this one. I can see the clock out working as well. But this pin's low, so I'm starting to suspect that I have an issue with this microcontroller. But I'm starting to suspect that it's actually the reset circuitry of this unit somehow holding this thing in reset. And that would make sense, because before this unit was working, and then it kind of faded out. Yeah, it faded out working. I've also I don't believe it's the LCD anymore, because the LCD, if you notice, just as you restore power to this unit, the LCD flashes and comes on. So I think there's power. You can see the LCD receiving its 22 volts, and you can see the LEDs flash on, but then they turn off. And there is, looking at the manual, there is actually the CPU actually controls the LCD backlight power, as well as actually what's actually going to be displayed on the LCD itself. So I think it's this guy that's somehow not working. But yeah, that solder bridge, it just really surprised me. So I'm going to remove that solder bridge, try again, see if that fixes anything, and then I'm going to start debugging the reset circuitry and see where that goes. So I don't know if you can see, but I actually have a working system. But what I did was a little bit dodgy. So I've been tracing out what the problem is, and I've noticed that this that the not reset pin for this, as well as the one for this, are actually held in the reset state. Now, what that line is actually driven ultimately by the chip over here, and this is the power controller chip, this one here, and its job is to provide memory to this battery backed up RAM up here, power up to this RAM from this battery whenever the voltage drops below a certain amount. But it also at the same time monitors the main power line and then sends out a reset signal. Now that reset signal is high when it should be reset, so it comes all the way over to this side of the board and gets to this hex inverter here, where it is inverted, and it becomes the reset signal for the CPU, or the not reset signal for the CPU, and then it actually goes through a hex inverter again. So this first two pins here are the first on the first pins on here are the input, then the output of the first inversion. Then there's the input and output of the second inversion out to the reset line of this. So obviously this is a not reset, this is a reset. So you get a reset that becomes a not reset for this one, that becomes a reset for this one. Now somewhere between it being, the reset line for this chip and then going into the hex inverter to become this reset, then the not reset for this and then reset for this, the line was getting pulled down to 200 millivolts. And I think it's this hex inverter. Because I tried some things. For example, there's a 0 ohm jumper up here, and this actually isolates one part of, I think, clock mod, whatever that does in this. So I tried removing this to see if it was this that was loading down the line. And actually, if anything, the voltage went lower. And what I know is there's a pull-up over here. And this has actually will have an internal pull-up as well. So by seeing the voltage go lower on this rather than go higher, I actually figured that this wasn't pulling the line down. So that led me to think it was this hex inverter itself. So what I then did was I actually did something a bit rash. I actually decided to connect 5 volts directly to the tip of my probe from the actual power supply, and I touched this from one of the power lines, the 5 volt power lines, and I touched the actual part here which goes to this reset line and goes to this one. All of a sudden the unit started drawing about half an amp at 5 volts, and I noticed this hex inverter got hotter and hotter. But the system was flickering. I was flickering a lot. So I held it in there for a bit, and actually what happened was I turned it off and on a few times while I was doing this, and sure enough it came back to life. And so we actually have the unit complaining that it can't find the required number of measurement boards, which is not surprising. Why I put 5 volts in there and give you some of the logic. I mean, it was a 50% kind of dangerous guess and 50% education. So let's explain that. The dangerous guess was I knew that I wanted the reset line to be high, so I just decided to put 5 volts in. But the guess, that's the guess part of it. But the education part of it is I know that the logic in there is 5 volt tolerant. Everything in there was a 5 volt logic system. So if anything was working, it should have been able to tolerate that 5 volts, especially because everything it was connected to was either an input or a driver, and there was only one driver in there, and that was the hex inverter. So in order to explain it and explain how I got to that position, I'm going to rely on actually looking at this power meter clip component level, I don't know, I'm not sure what the IP stands for, but component level service guide. Now this was kindly sent to me by a member of the HP Agilent Keysight forums on groups, Google groups, which used to be the old Yahoo groups, has moved over to Google now. And there's a lot of knowledgeable and very generous people there who one of them sent me this power meter clip, which I couldn't find on the Keysight website, although I could find all the other manuals. Anyway, what's great about this clip is that it actually has a ton of information, including schematics, on things like the processor board, the interface boards, and the measurement boards. So if I hit processor schematic, what you're going to see is a blank page, but then the actual schematics themselves. What's really nice as well is that we have these the actual component loadout for the processor board. So what you can see is the processors here, the hex inverters here, this U2 is the hex inverter, and then all the way over here we have U1, and that is the power controller. So just to recap what's happening here, I have this 32-bit microcontroller. It has a reset and a halt line, and these lines are tied together. And then if you follow these lines, this pin 68 and pin 69 down, there's a line that comes across like this over to here. One way goes towards this debugging header, and the other way, the other way comes along. It branches out through the 0 ohm jumper back into this mod clock, and then you see this connection here out to 10k PU7. That's a 10k pull up to 5 volts. If you search for that, you just find it's a resistor pulling up to 5 volts. And then if you follow the line down, you get to the hex inverter, which is actually driving the line. So you have a 5 volt pull up up here with a mod clock, and then you also have a 5-volt pull up here, a 1K 5-volt pull up here, and then you get to the hex inverter itself. And this is the one of the inverters. It's a hex inverter, so it has 8 of these, but only one of them is used to drive this line. And what you'll notice is the line is also connected to the input of another hex inverter, and it goes from being the reset line to being the low reset line. So if this line is low, then you're actually holding the CPLD in reset. So if we just follow this along, it resets the real-time clock. But if you actually search for this L reset line, you'll find that that's actually connected to the CPLD, which is just down here. Yeah, so there's the CPLD, and there's its L reset line. Also, they're connected to. I'm not sure what the clear is there, but output enable is connected in that way. Okay, so clearly this hex inverter is meant to be driving this line, but I was seeing this line at 200 millivolts, which implies that something is pulling it down. I wanted to see if it was this microcontroller, so I did desolder this 0-ohm jumper and just check, and I saw this come up to 5 volts. So it's clearly not this mod clock line that's actually pulling this down. Now, if everything's working, I can put 5 volts on this gate, on this line. The only person who might disagree with that is the hex inverter. So these hex inverters are open collectors, and that means they can't pull the line high. It's always pulled by high by these external resistors, but it can pull the line low, and essentially it's a transistor, so it could actually sink quite a lot of current in order to kind of pull this line low. And my feeling is that this inverter, or this part of the inverter, was actually dragging this line down. That's what I thought it would be. The only other real possibility is the input of the same hex inverter, just a different gate. That could be somehow pulling the line low, or alternatively, the microcontroller itself could be pulling the line low. Now, if this microcontroller is pulling the line low, then it's probably had some kind of catastrophic failure, and at that point, the whole thing's beyond economical repair. I can't really find a new one of these microcontrollers. Or if I did, it would probably be in looking for another one of these boards, and plus they're a nightmare to replace. So, if putting 5 volts in and there's a short here, then already this chip's gone, and I'm not going to do any more damage just by putting 5 volts into the processor. But if I put 5 volts into here, what I might do is burn out the short, or burn out the gate or the driver that's the driving transistor that's on this hex inverter, and that will allow the line to actually come up to 5 volts again. At least that was my theory. So that's what I decided to give a go. I mean, I did check this line coming from this power supply monitor is was low, which is correct. It wasn't in the reset state, so this power supply monitor was doing its job. It was pulling this line low, but this output here was low as well instead of being inverted. I did, of course, check, by the way, that the 5 volt supply to this chip was absolutely fine, and it, of course, was. So yeah, okay. So I put the 5 volts in here, and I think what I've done is burn out the output transistor on this that was somehow being held low. And the real problem here is, where does that leave this whole reset line? I mean, the whole thing is being pulled up by the 5 volts line continuously. It never goes low. So what have I damaged? Well, I think what I've damaged here by burning out this gate is the brownout protection. So the reason why you have this line being pulled low by the power supply monitor is if your voltage drops below a certain point, and you don't want your microcontroller to be operating when you're in a brownout condition, because it might get into an undefined state and then it might hang up. What you'd rather do is properly reset the microcontroller whenever you had a brownout condition. Now, do I need this? Well, given that I have a soft start, I have a soft switch at the front, we're going to get a pretty clean transition from power off to power on anyway, because the power supply switch is on, and then we enable the rails. So I'm not worried about a brownout condition on switch on, and on switch off it's the same point as well. I really think this brownout protection is there for when you're actually battery supplied. So these units can actually have an internal battery as well, which I don't have on mine. So again, I'm not too worried about this. I mean, I could have done something else. I could have cut this trace. Alternatively, I could have cut this trace here instead of just trying to burn out the gate on this one. And you know what? That's probably a far more sensible thing to do, was to just cut this trace and try and operate the system like that.
Um, yeah, okay, okay. Hindsight's 2020. I kind of wish I'd done that now. But as it stands, it does all work. It seems to be working. There are a few more gates on this hex inverter. The ones that I checked out seem to be working all right. I seem to have limited my damage to just this one already broken gate. So I think I got away with it this time. But what I will do in the future is definitely replace this hex converter. I mean that's gotta be replaced. Um, because this brownout thing will eventually, Murphy's law, it will eventually come and bite me in the ass at some point. Okay, hopefully that makes it clear as to why I did that. I think now, thinking about it, I'll cut the trace in future rather than try and burn out a gate. Um,
And as you can see, the self-test is actually passing, so all I have to do here is hit System, go to my Service menu, Self-Test, Instrument Self-Test, and sure enough, everything seems to be working. So my Frankenstein resurrection of the hex inverter at the back seems to have worked for now. I don't believe it'll hold, but I don't think I'm going to do another video where I just replace that, because that's a pretty straightforward replacement. So about the only thing I want to do here is actually get my sensor cable and attach it to channel A. I'll put my sensor on the power output at the back. Let's see if it detects the sensor. Okay, so that's on. And yeah, correction factor 100%, that's fine. So let's go into the system and let's just see if we turn the power reference on, 1 dB. I thought it was a 0 dB, maybe it's a 1 dB output, but let's calibrate. So first of all, at 0A, and you see the power reference is off at the back while it zeros. Then we should probably see around about 50 on here. Okay, that's fine, and then we calibrate. Right, so now what I'm going to do just as a test is actually put the power reference on, and there you are. It looks like everything's working how I'd expect it to work for this sensor, and so I think that's a successful repair for now anyway. Surely I'll have to replace that X inverter later. So I thought I was finished. What I've done is I've bought a nice set of rubber bumpers and a foot stand. I also, a friend actually epoxied this for me, so this broken back plane is now actually quite well secured well. So I've got to just put the screw back in and pop this into the back, and then put the rubber bumper on the back, and it'll all be done. I then upgraded the firmware, so if you have a look here, in the version, that's the latest version of the firmware now, 2.0901. So I'm pretty happy, everything seems to be alright, except I noticed one more problem, and that is that button. That button doesn't work, and unfortunately behind that button are the tables, the calibration tables. Now I can try, I can calibrate, for example, channel B by manually, so I could switch to using channel B. I only have one power sensor anyway, but you can see, annoyingly, I can't access the tables. I can't dial in the table of calibration factors. Obviously this repair is incomplete. So what I'm going to do is I'm going to put it all together, but when my hex inverter finally arrives from, I think it's Israel, in about a month's time, what I'm probably going to do is try and finish this off by repairing this front membrane. I've also noticed that this button is pretty unreliable as well. You can see it's changed to sensor B, but now it's changed back to sensor A. Every other button seems to do work just fine, but that button there and that button there, so somehow they're maybe on the scan line. I mean, I would have said it was just the buttons, but I think now, because there's two buttons that have failed, it's probably on their particular scan line that they've failed. Oh, save and recall is dead as well. Yeah, it's looking like maybe a bad cable. Yeah, absolutely everything else works, but for that button, save and recall, and that button. So what I'm going to have to do is look at how those buttons are wired on the front panel, and it's probably the cable's bad, and so I might need to find a new cable. You can get new flex ribbons for these cables on eBay as well from China. So anyway, that's a repair for another time, but for now this works pretty nicely. I do have one problem with my setup. My power reference output is on the back. That's pretty annoying. I mean, it's pretty good if you've got a rack mount system, but it's pretty terrible if like me, you want to use it as a bench one. So I might look as well, if I can find a scrap meter, I'll try and repair it, but I might steal the kind of front cabling to put this out front before I send this away and get it calibrated.